All right, so today we are going to be talking a little bit about geometry. Now, a lot of you guys have probably taken geometry or are currently in geometry. How many of you guys are in geometry currently? A couple? All right, so how many of you guys have already had geometry? How many of you guys haven't had geometry? Okay, so there's only a couple of you that haven't. All right, good. So I'm not going to focus on a lot of the vocab and stuff from geometry. I'm going to try and go over some of the basics that you need for this class and for the SAT, and really what you'll need for the exam. But I'm going to try to avoid using a lot of the extra vocab, because as you guys know, there's a lot of vocab that goes into geometry. Now, the first thing that we're going to talk about, the first section here, will be about lines and angles. Now, the good news is that for a lot of the geometry, there are formulas for some of the stuff. Now, there's not formulas for everything. So, under lines and angles here, the first mini title we're going to have is length and midpoint. So, this is the first idea that we need to go over. Now, for length and midpoint, there are formulas for both of these. Now, if you're trying to find the length of something, what formula are you actually using to find the length? Another way of saying that you're finding length is by finding the distance. All right. So, like the distance between 2 points gives you the length of a segment. So we're going to use our distance formula. Now, that's overlap from algebra. And again, most of our topics up to this point have been based on algebra. So, distance formula, x2 minus x1 squared plus y2 minus y1 squared. And that's all underneath a radical. And that gives us the distance. For the midpoint's in the middle. So it's an average of your 2 points. So for midpoint, and this one's also a formula. But these are pretty much the only two formulas that we're going to go over today that are not on your reference sheet for SAT. So to find midpoint, you do the average of the two x values. So x1 plus x2 divided by 2. Oops, that's an x. And then y1 plus y2 divided by 2. So that's, again, length. You use your distance formula. Midpoint, you take an average of the x values and average of the y values, and that gives you the midpoint. The next idea that we need to go over is measures of angles. Measures of angles. So there are 4 main angles that we need to talk about. Acute, right, obtuse, and straight. For an acute angle, how do you classify an acute angle? How do you classify an acute angle? Less than 90? Yeah. And if we want to be really specific, we'd also say that it's greater than 0. So any value for an angle that is between 0 and 90. For a right angle, exactly 90. For an obtuse angle, greater than 90 but less than 180. Yeah, so this is fall between 90, and 180. And then a straight angle, 180. So those are the main angles that we need to know by their measurements. Now, this next one you use in geometry a lot when solving for different measurements. Vertical angles. So if I drew two lines intersecting, and I label these as angles 1, 2, 3, and 4, what angles could I call vertical angles here? So there are two sets of vertical angles. 4 and 3, 1 and 2, yeah. So angle 1 and angle 2, angle 3, and angle 4. That's my and symbol. That's not a plus sign. Just making sure you know that. Now, there is something else you should know about vertical angles. What's true about the measures for vertical angles? The measures are equal, or you could say the angles are congruent. So you could say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Which again, when you say something's congruent, you're saying it's the same, so they have the same measure. All right? So their values will be equal. The next idea, supplementary and complementary. So, what's the difference between supplementary angles and complementary angles? In both cases, we're talking about two angles. This one, two angles that add to 180. For complementary, two angles add to, what complementary angles add up to? 90, yeah. So supplementary add up to 180, complementary add up to 90. Now, there's a lot of confusion, I think, when we talk about supplementary, because if I was to draw a couple of diagrams here, 1 and 2. All right. So, on the first one that I drew in green there, what can I say about angles 1 and 2? They are supplementary. Now, there's a lot of other vocab words in geometry. All right? Like, I can describe the angles 1 and 2 and the angles 3 and 4 here as being adjacent. So these two are adjacent, these two are adjacent, meaning they're next to each other. I can also describe angles 1 and 2 as being, since they're adjacent and they're forming a line, they're a linear pair. All right? So again, yes, this is a set of supplementary angles. But they don't only have to look like that. Same thing down here. 3 and 4, that's a set of complementary angles. But they don't have to necessarily look like that. If we had angles that were completely separate from each other, like we do over here, 30 and 60 add up to 90, so those two would be complementary. 30 and 150 add up to 180, so those would be supplementary. So again, they don't have to be next to each other. And that's what a lot of people get mixed up on when it comes to supplementary and complementary. They don't have to be adjacent angles to be supplementary or complementary. Again, they can be separate or not connected to each other. Now, going along this same idea of supplementary and complementary, we also have angle addition. So we can have angles that add up to other things. Now, angle addition is specific to adjacent angles, angles that are next to each other. So if we were to have, I'm just going to call this angle 1, angle 2, and I'm going to label these as well. A, B, C, and D. You can label angles different ways, but one thing I could say for sure about this is that the measure of angle 1 plus the measure of angle 2 would have to give us the measure of this overall angle, angle ABC. So again, we're not getting a lot into how to name angles and things like that, but just know if they give you numbers that aren't measurements, you can use those to name an angle. Or if they give you letters, you can use the letters to name the angle, where the middle letter is your vertex. Another idea that you need to know, which again goes along with the idea of angle addition, sum of angles around a point. What is the sum of all angles around a single point? How about this? How many degrees are in a circle? 360. Right? If you do a complete rotation, that's 360 degrees. Let's see, what's coming up? We have Summer Olympics are coming up. If you're watching a skateboarding event and a guy spins completely around, that's called a 360, right? Yeah, same idea. If you do a complete rotation around a single point, it should be 360 degrees. Now, all right, let's see. Properties. This last one is one that I spend a good deal of time on in geometry. There's like a whole section for this one. But we're going to try to do it without any of the vocab, which makes it a little bit easier. Properties of parallel lines and angles formed with a transversal. So, I'm sure everybody in here that's been in geometry, either this year or previous years, has seen this diagram before. Now, I'm not worried about naming any of these angles. All right. If you've been in geometry, you know there's all sorts of names that go with these. Corresponding, same side interior, same side exterior, all those different things. And there's a bunch of different properties as well. What we need to know for this class, for the SAT and for our exam and stuff, is just how do the angles relate to one another? So in here, when we have a set of parallel lines cut by a transversal, again, transversal is just a line that intersects more than one line. There's certain properties that form. 4 of these angles have the exact same measure. All 4 of those acute angles should be congruent. Also, all 4 of the obtuse angles should be congruent. So, I'm marking them as congruent by using the same number of arcs in the ones that are equivalent. So, in this diagram, all the acute angles are congruent. All the obtuse angles are congruent. Again, I do geometry all day long. I use a lot of abbreviations. So if you don't like to use abbreviations, again, this is saying all acute angles are congruent. So then all obtuse angles are congruent. Kind of windy out there. All right. Now, what's true if you take any obtuse and acute angle together? So any pair of one acute and one obtuse together are what? What do you think? So let's pick a pair that's next to each other. These 2 angles form a straight line. Therefore, they're a linear pair, and therefore they are supplementary. So any pair of one acute and one obtuse angle are supplementary. So again, we can talk about the relationship of these angles without using a lot of the other vocab that goes with this section. Again, the main thing you have to know is what is their relationship, right? So all the acute angles are congruent, all the obtuse angles are congruent. Any combination of one acute and one obtuse are supplementary. You have to add up to 180. Now, if you're in geometry, yes, you should know the vocab because they could use some of those other vocab words when it comes time for the FSA. But that helps with the majority of these problems. Now, up to this point, everything that I've written out in notes so far today, this is all focused on lines and angles. Lines and angles is the biggest section of geometry that you could come across in the SAT. It's also, for our exam, this is probably the only part that you will see on the exam. When I looked through the review that the county gave us, these are the only types of problems that they have on there. Now, are there other geometry problems that you could see on SAT? Yes. All right. These are the only ones I'm forcing you to take notes on. These are the ones that I'm going to give you guys problems on starting tomorrow. Now, I'm going to do a few other notes. Again, they could help you out with, if you're currently in geometry, they might help you out. Also, they could help you out on the SAT. But again, this is where what we're focusing on stops. All right, so I'm going to go over a couple other main ideas. Now, are there other harder concepts as well that I'm not going to go over today? Yes, there's a lot of geometry ideas that could be on the SAT. But the SAT is only going to have about 10% geometry. That's it. It's a very small percentage overall. So again, majority of the topics are usually from here. I'm going to go ahead and hit on a couple other main ideas that do come up often, and then we'll be done for today. So this is the main part of the notes that you need to be worried about. The other things that we're going to cover right now don't have to be as worried about. So the next section, I'm not even going to write a whole lot down for this. Like I said, I'm not going to test you guys on this stuff. from this point on. So area and volume. Now for area and volume, you really don't have to know a whole lot when it comes to the SAT. You have to know how to use some formulas. But if you've noticed in the SAT practice test that we've done, the only formulas that are given to you at the very beginning of the section are all geometry formulas. So when it comes to area and volume, they're all here. All the ones that you very much need. Now, they might also give you a trapezoid, and trapezoid isn't listed here. But in order to get a trapezoid, you could do a rectangle into triangles. And you could find the area using that. Right? Could you memorize other formulas that would help you out? Yes. But again, you should be able to do the majority of any area problems or volume problems with the formulas that are given to you at the beginning of the section for math. They also give you some other important things, like down here, we talked about points around, or degrees around a point. They say on here, number of degrees in an arc of a circle, 360. So they kind of give you that idea. Right? They also tell you the sum of the measures of all the angles in a triangle is 180. Again, they give you some important ideas there. So for this section, instead of writing out all these other things, all I'm going to say is look at the reference sheet. Again, they give you most of what you need for that section on the reference sheet. So they give you area formula of a circle, of a rectangle, of a triangle, volume formula of a prism, a cylinder, a sphere, a cone, and a pyramid. They give you all that. So use the reference sheet. Again, I can't stress this enough. Use the reference sheet. Look. Now, I want to go over these real fast, but again, these two are on the reference sheet. All right, but there's two main topics when it comes to triangles that you see a lot. I just want to explain them briefly. So one of them is Pythagorean theorem, which you guys have probably seen many, many, many times because it's covered in algebra and it's covered in geometry. And if you're currently in geometry, you haven't even got to the section where you learn about Pythagorean theorem more, but you've probably done it in every section already. It's literally in like every single section that we talk about. If there's a triangle, they pretty much have Pythagorean theorem in that section. So, you can look at Pythagorean theorem one of two ways. I always write it this way. C squared equals A squared plus B squared. Some people prefer writing it in alphabetical order. A squared plus B squared equals C squared. It's the same thing either way. What it is a way of finding the missing side of a right triangle. So if you're given a right triangle, the side across or opposite the right angle will always be C, your hypotenuse, the longest side. The two sides that are next to the right angle are going to be A and B. Those are your two legs. Again, the legs of the right triangle are always next to the right angle. So this is just a way of finding one of the missing sides. If you're given two out of those three pieces, you can find the third piece. Now, there are also what we call special right triangles. Oops, I started abbreviating. It's fine. Special right triangles. There are two special right triangles. And whereas normally you need two pieces to find a missing side in a triangle, for the special right triangles, you don't need two pieces. You only need to know one. So the two special right triangles that there are 30, 60, 90, and are 45, 45, 90. And these names are based off of the angle measurements. So in 30, 60, 90, we have a 30-degree angle, a 60-degree angle, and a 90-degree angle. In a 45, 45, 90, we have a 45-degree angle, a 45-degree angle, and a 90-degree angle. Now, in the 45, 45, 90, this is also called an isosceles right triangle. So all isosceles right triangles are 45, 45, 90. So if these two angles are congruent, the sides across them are congruent. Now I'm going to call both those x. The hypotenuse will always be one of those legs times the square root of 2. In a 30, 60, 90 triangle, the short leg I'm going to call x. If we know the short leg, the hypotenuse will always be double the short leg. The other side, the long leg, will always be the short leg times the square root of 3. Now again, these two figures are on your reference sheet. So again, use your reference sheet. They come in handy. Last part of this, we're going to talk a little bit about circles. And these will be our last ideas that we talk about today. So in a circle, we need to know some of the specific parts. We need to know what a radius is. We need to know what I almost skipped over one. What the diameter is. And we need to know what the circumference is. Now, are there other parts to a circle besides these three? Yes. But again, these are the three main ones that we need to talk about. So again, in a circle, and my center point to the circle, the distance all the way across, going through the middle of the circle, is the diameter. Half the distance, so from the center to the circle, is our radius. The distance around the circle itself, that's our circumference. And we find the circumference with the formula 2 pi r, or diameter times pi. Now again, like I said, use your reference sheet. They give you, which one do they give you? I forget. For a circle, they give you this first formula that works for the circumference. So again, use that reference sheet. Two other things that we need to talk about real quick for circle. So this next topic, central angles and inscribed angles. So, a central angle is exactly what it sounds like. It's an angle on the center of the circle. If I call this angle measurement x, the measurement of the arc out here would also be x. Now, in an inscribed angle, if this measurement was x, the arc intercepts is 2x. So a central angle has the same measurement as the arc it intercepts. An inscribed angle has half the measure of its intercepted arc. This last circle I drew here, what I want to show is if we have an arc, I'm going to darken part of this in purple. Can you tell that up there? That part there I just shaded on. If I had two separate angles intersecting that same piece, then these two angles would be congruent because they're intercepting the same piece. So no matter how you do that, half of that measurement is always going to give you the same number, right? So those two have to be congruent. All right, last topic, last idea. Tangents. Now, there's a lot of properties involved in tangents. There's only one that I'm going to talk about today. So again, when we have a circle, a tangent is a line that intersects a circle in exactly one spot. If we were to draw a radius in the circle to that point of tangency, it makes a right angle. Now my circle is a little lopsided there, so it's not perfect, but that's the only property I want to go over with tangents. Again, that's a lot of different ideas that we went over today for geometry. A lot of geometry for one day. So we're going to stop there. Like I said, what we did with the lines and the angles in the first part is the most important part. All right. Again, these other topics that I went over, they're things that you definitely would probably see on the SAT. But again, the SAT, every time you take it, it's a little bit different. And the geometry topics only make up about 10% roughly of the SAT. So you won't see every single one of these topics used every time. Again, you'll get a wide variety of them. Some of the other things that we talked about with the algebra, you're almost guaranteed to always see problems using things like mean, median, mode, and range. You'll almost always see a few questions on those. You know, geometry, you'll see a few questions, but they won't always be on the same ideas. So, yeah, that's another reason why it helps to take the SAT multiple times, because sometimes it might be easier to you than others because of the types of questions they ask. Whoops, I hit the wrong button. Yes.
Can I go to the restroom?
Yes, you may. Let me go get the pass out of my desk.